Okay, so here we are given data points and we're going to put it in standard form. So we can use standard form. One, we don't know the vertex and we don't know the root, so we have to, and we can because my x values are consecutive from -1 to 0 to 1. So I can find my a, and I have been given my y-intercept. So we need an a value, a b value, and a c value. So just as a reminder, standard form. When I'm working these problems, if I were you in my notebook, I would have all these forms out. I can remember them easily because I've been teaching this for quite some time. So my C value is -1. To find my A value, we're going to find the first difference from 4 to -1 is going down 5. And then from -1 to -8 is going down 7. So that's called the first difference. Now to find the second difference, from -5 to -7, that gives me going down 2. So that's my second difference. So your A value is the second difference divided by 2. So now we are going to plug in what we know. We know A is -1. We do not know our B value, and we know C is -1. We're going to take a point other than the y-intercept. We've already used it here, so we can't use it again. So I'm just going to take this point right here and plug in for x and f of x. Oh, that should be a squared right there. I knew something was missing. Let's simplify. -1 squared is 1 times this -1, so that's -1. B times -1 is -1b. We're going to combine like terms, and now we're going to solve. Divide by my -1, and my b value is -6. So when I put that all together, -x squared minus 6x minus 1. My y-intercept 0, -1. Okay, so we need an A, a B, and a C. My C is -3. My x values are consecutive, so I can find the pattern of the first difference. So that's going down 3, and this is going down 1. First of all, this tells me this was not a linear function. So that's my first difference. Now my second difference, this is going up by 2. So my A value is my second difference divided by 2. So let's plug in what we have. A is 1. B we do not know, and my C is -3. I'm just going to use this first point again. It is one of the roots. I'm going to plug that in for x and f of x. -1 squared is 1. B times -1 is -1b minus 3. Combine like terms and solve. I get 2 equals -b. So we can put that all together. And we get 1 times x squared minus 2 times x minus 3. Y-intercept 0, -3. Okay, here we're given a graph and we're going to write the equation in standard form. So again, standard form. So I'm not going to go directly from standard form because I don't want to use a function table. So I'm going to, because my roots are easily seen or my vertex, I'm going to do factored form. And so one root is -2, 0. The other root is 6, 0. And then I can either use the y-intercept, 0, 0, -6, or I could use my vertex. So that will be 2, negative 8. Okay, so I'm going to convert it to standard, but first I am going to use factored form. So I have x minus negative 2, and I have x minus 6. I'm just going to use my point, my y-intercept. So I'm going to use my y-intercept as my other point to find my a. So f of x is going to be negative 6. 0 will be my x value. So I'm using point 0, negative 6. I get a times 2 times negative 6. I get negative 12 times a. And my a value is positive 1/2. So I have 1/2 times x plus 2 times x minus 6. Now I need to convert it to standard. I'm going to multiply my binomials. Combine like terms. And distribute my 1/2. So I'll write my final equation up here. 1/2 x squared minus 2x minus 6. My AOS is x equals my vertex, which is the x part of my vertex, x equals 2. My y-intercept is 0, negative 6. My vertex was 2, negative 8. My zeros are negative 2 and 6. My range is all real numbers, or my domain is all real numbers. My range, the least number this can be is, remember, it's right here. It's the y part of your vertex. So from negative 8 and up. The area, so let's put in, remember your AOS helps you with intervals of increase and decrease. So this graph is increasing on the right side of your AOS. So from 2 to infinity. So from 2 to infinity it is increasing, and from negative infinity up to the 2, the graph is decreasing. Okay, our AROC from negative 4, so from negative 4, which is way off the graph, to 0. So we need 2 points, excuse me, 2 points. So we need 1 point where x is negative 4, and the other point is where x is 0. We already know when x is 0, our output is negative 6. Now we just need to plug in negative 4. Excuse me. I can plug in negative 4 to my equation to get the output. So I'm going to work over here. So I am plugging in negative 4 for my x. So I get negative 16. I get negative 4 squared, which is 16. And then we have 16 times 1/2, so that gives me 8 plus 8 minus 6. So I get 8 plus 8 is 16, and 16 minus 6 is 10. So when x is negative 4, y is 10. So I have my 2 points, and AROC is just finding the slope of your secant line between negative 4 and 0 of this graph. So we're going to do y2 minus y1. So y2 minus y1 over x2 minus x1. And I get negative 4. So the AROC is negative 4. My end behavior as x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x also approaches positive infinity. They both go up.